Hi everyone, my name is Daifeng Liang. I'm the current student of Master of Liberal Arts in Extension Studies, Data Science at Harvard Extension School, Harvard University. Today, I would like to share my final project for the course CSCIE 222 Large Language Models, lectured by Professor Dimitri V. Kurakin, PhD. And today I will share a short business-facing version of my LM assisted RAG project and why I think it is relevant to corporate tax advisory work. My core idea is not to build a general chatbot that answers tax questions for Mary. My goal is to build a source-routed research assistant. It retrieves the relevant page, table row, or note first, then uses an LM only to summarize the evidence. That distinction matters because in tax advisory, speed is useful only when the answer remains traceable and reviewable. The direct connection to corporate tax advisory is the research workflow. Many tax questions are not conceptually hard, but they are easy to get wrong because the answer is located in a table, a footnote, or a narrow jurisdiction-specific exception. A normal chatbot may produce a polished answer, but it can still pick the wrong source or mix rules from different sections. The usual workflow, as you see in mine, for practical use case is evidence first. I would like to develop a tool that narrows the search space, shows the supporting source, and helps the advisor validate the conclusion. That is where this prototype fits. It speeds up first pass research, but keeps human review in the loop and professional judgment at the center. My prototype started with a very practical problem. PDFs are not simple text. In text guides, the answer often lives inside a table, a row, or a note. If we chunk the PDF too broadly, the system may retrieve the correct page, but lose the exact row. If we chunk too narrowly, the system may lose the section context. The final artifact therefore preserves page numbers, section titles, content type, and row or note context. That is why I describe this as a retrieval-first system. The LM is important, but the source structure is the foundation. This is the simplest explanation of my architecture. A user asks a text question. The retriever searches the reserved chunks of evidence stored in vector database. The re-ranker chooses the strongest evidence. Only after that does the LM write the answer. This means the LM does not read the full PDF directly each time. It receives a much smaller prompt containing the system's instruction, the question, selected evidence chunks, and the metadata or citations. That is important for both accuracy and cost. It reduces the chances of unsupported answers, and this makes token cost proportional to the selected evidence, not a full document size. My project evolved in three phases. First, I built a NoLM and local retrieval pipeline in Google Colab from version 1 to version 5.2. That phase focused on parsing, chunking, page awareness, metadata, and re-ranking. Second, I moved the same artifact to AWS SageMaker to deploy on Streamlit web app and tested three modes: NoLM, OpenAI, and Bedrock Nova Micro. Third, I moved the current version to Azure Foundry AI with Azure OpenAI in the same model version, GPT 4.1, and deployed Streamlit in Docker on Azure Container Apps. The important point is that the evidence layers stay consistent. The answer generator changed, but the retrieval remained the backbone. My current version is no longer just a notebook. It is a Streamlit application deployed through Docker and Azure Container Apps. That is why I see it as a more realistic internal prototype. The Azure app supports a NoLM evidence mode and an Azure OpenAI answer mode. It also makes the application easier to demonstrate because the web URL is stable. From a governance perspective, my design is also cleaner because the API key and endpoint are environment variables or secrets, not code values committed to checkout. The preserved version 5.2 benchmark showed strong retrieval performance. Top K retrieval hit was 1 and top 1 retrieval hit was 0.98. In the revised cloud benchmark, all modes found the expected pages. That is the result I would emphasize for an advisory audience. My system is good at finding the relevant source. The answer generation matrix are more nuanced. Exact match was low because a string matching is harsh for long nodes. But value lookups such as rates and threshold were strong. For my work, the best evaluation is layered. Did it find the source? Did it answer from the source? And did the scoring rule judge the answer fairly? My project is a strong cloud deployable prototype, but I would not call it production ready. It has evidence only answering, citation display, and abstention instruction, which are good RAG safety controls. However, production would require more. My project currently uses local embeddings rather than a managed vector database. It does not yet use Azure AI Search, Android user authentication, key vault, full observability, CI/CD, or load testing. For a text domain, the responsible boundary is also clear. This is source lookup and summarization, not autonomous text advice. A reviewer should validate the final conclusion. Question 6 is the quality control slide. I intentionally used a wrong expected answer as a trap. The goal was to test whether the model would simply match the expected label or whether it would follow the source evidence. The results was encouraging. The Azure OpenAI and AWS OpenAI was correct according to the text facts and evidence. Even though it failed the autonomic expected answer check, for advisory work, this is very important. It shows that I should not rely only on exact match matrix. I need source-grounded review, negative control questions, and expected answer validation. A model that disagrees with a bad label may actually be doing the right thing. This is a cost explanation I would use with AI governance and financing. The billing unit for hosted LLM columns is tokens, not PDF pages. Because this is a rack system, the PDF is already preprocessed into chunks. At answer time, the LLM does not read the entire PDF. It only sees the system prompt, the question, and the selected evidence chunks. So cost per answer depends on how many chunks we include and how long the model answer is. Cost per PDF page only makes sense during indexing or refresh, especially if I use a hosted embedding model. In this prototype, the embedding model is local, so embedding token cost is not the main cost. Cloud hosting and LLM costs are. This is where I would play with the Streamlit. I would start with no LLM mode because it proves the retrieval layer by itself. Then I would switch to Azure OpenAI mode and AWS Bedrock mode and answer narrow questions, just text rate, threshold, or filing deadline. I would point out that the answer is useful only because the app also shows the retrieve evidence. I would mention question 6 as trap questions. The expected answer is intentionally wrong, and the model passes when it follows the source evidence instead of the bad label. The key demo message is that this is not a black box chatbot. It is a source-grounded research assistant. Here's the LLM assisted RAG for Canadian corporate tax. Facts are deployed on the AWS-based Streamlit with the no LLM and Bedrock. I can choose a Bedrock for the pipeline. So you can see this is some Nova Micro version 1, and click Run. In the meantime, I can show you the Azure AI Foundry rack. So I already deployed the Azure AI deployment here with the GPT 4.1, and then I can run the pipeline as well. And you can see the difference. So back to the Bedrock on AWS, you can see that for this question 6, it answered 35%. However, the expected answer should be a full paragraph like this. For some reasons that with the capabilities and limitations of the Nova Micro version 1 or the Bedrock, so it picks out this portion of the final sentence in this paragraph to answer the real figure for these particular questions. But my intention back then for this question 6 is to cite the full notes in paragraphs for the ITC rate on total expenditure up to the expenditure limit for qualifying CCPCs under federal research and development tax incentives. If we scroll further down, actually it cited the correct page on page number 81. But it's just that the answer is shortened to 35%. If I look to the Azure AI Foundry, let me run again. Here, you can see that it already rephrased the full sentences in the full paragraphs. So as per the assessment scores or evaluation scores, the exact match shows false, even for the containers expected and value hit was false. However, if you read it line by line, text by text, word by word, and looking at the semantic similarity, not the lexical similarity, you can see that both answers are correct. This is the answer generated by the Azure OpenAI GPT 4.1, and this is the expected answer that I provided as evidence. And scrolling further down, you can see that these are the selected evidence from the rack that would be used and referred by the Azure OpenAI GPT 4.1. So back to the question number 1, for the more direct questions related to the filing deadline and payment deadline for federal corporate income tax returns under filing and payment deadlines, although that the assessment score that I set up very strict for the exact match contains expected and value hit, all those are false. However, if you read the rephrase answer generated by the Azure OpenAI GPT 4.1, it has the same meaning with the same components for the 3 sentences in one full paragraph. So this is my simple message. The AI tool shortens research time, but it keeps the evidence visible. For production or team pilot, I would track costs at 3 levels. First, the app should log usage for every call. Most hosted LLM responses include token usage, so I should save from tokens. Completion tokens, total tokens, model, mode, question ID, retrieve pages, and latency. Second, I should reconcile the app log with provided usage APIs or Azure Monitor Matrix. Third, I should translate technical usage into business KPIs, cost per question, cost per source routed answer, and cost per question type. If I did not save usage for past calls, I can estimate from saved prompts and answers, but exact historical usage requires provider dashboards, usage APIs, or logs that include the usage object. My recommendation is to treat this as a pilot pattern rather than a final task advice entry. The next step would be to curate a narrow advisory corpus, add review feedback, and track both quality and cost. The near-term benefit is faster first-pass research with evidence visible beside the answer. The long-term value is a reusable architecture, ingest documents, preserve structure, retrieve evidence, generate only from evidence, and evaluate retrieval separately from answer quality. For corporate tax advisory, that gives me a safe way to experiment with AI while preserving professional review and source traceability. That is the end of my final project. Thank you for listening.